Earth's magnetic field reversal isn't science fiction. It's science fact. The geological record tells us an undeniable truth. Our planet's magnetic poles have flipped hundreds of times throughout Earth's 4.5 billion year history. The last complete reversal happened approximately 780,000 years ago, an event scientists call the Brunhes-Montioma reversal. Since then, we've been living in what geophysicists consider borrowed time. These aren't just abstract scientific measurements. These are warning signs that Earth's magnetic dynamo might be preparing for something monumental. So, let's dive deep into what a magnetic pole reversal actually means, what the science tells us will happen, and how this will affect every aspect of life on Earth. To understand what's coming, we first need to understand what's happening nearly 3,000 kilometers beneath the surface. Earth's outer core is a roiling ocean of liquid iron and nickel, heated to temperatures exceeding 4,000 degrees Celsius. These currents generate electric fields, which in turn produce magnetic fields, creating what scientists call the geodynamo. This dynamo has maintained Earth's magnetic field for at least 3.5 billion years, but it's not a simple, stable system. The evidence is mounting from multiple sources. Satellites like the European Space Agency's Swarm constellation continuously map Earth's magnetic field from orbit. They've detected rapid changes in the flow patterns of the outer core, particularly beneath South America and Southern Africa. When scientists analyze historical records preserved in ancient pottery, bricks, and sediment cores, they see a pattern. The current weakening matches the signature of previous reversals. So, what exactly happens during a magnetic pole reversal? The process takes anywhere from 1,000 to 10,000 years to complete, though some reversals may have occurred in as little as a century. During this transition, the magnetic field doesn't disappear entirely, but it becomes significantly weaker and far more complex. Instead of two poles, multiple magnetic poles can appear scattered across the planet. The field strength can drop to as low as 10% of its current value. The protective magnetosphere becomes distorted and allows more solar radiation to penetrate closer to Earth. Let's talk about what this means for our technology first, because this is where we'll feel the immediate impacts. Our modern civilization is utterly dependent on satellites for GPS navigation, weather forecasting, telecommunications, internet connectivity, and scientific research. Every single one of these satellites is vulnerable to increased radiation exposure. Currently, satellites passing through the South Atlantic anomaly experience high rates of electronic errors and malfunctions. Engineers add extra shielding and program satellites to shut down sensitive instruments when passing through this region. But during a full reversal, these radiation hazards won't be confined to one area. They'll be global and persistent. The space station will require additional shielding. Astronauts will face higher radiation doses. The entire satellite industry will need to redesign spacecraft with enhanced radiation protection, making them heavier and more expensive to launch. GPS systems face particular challenges. These systems rely on atomic clocks and satellites to maintain precision timing. Radiation can disrupt these clocks, leading to position errors. In a world where we use GPS for everything from driving directions to precision agriculture to aircraft navigation, even small degradations in accuracy could have cascading effects. Now, let's consider our power grids. The magnetic field shields us from solar storms. When the sun releases massive bursts of energy called coronal mass ejections, these waves of charged particles slam into Earth's magnetosphere. Normally, our magnetic field deflects most of this energy, but during a reversal, more energy can penetrate to the surface. This energy induces electric currents in power transmission lines. In 1989, a relatively moderate solar storm caused a cascade failure in Quebec's power grid, leaving 6 million people without electricity for 9 hours. During a magnetic reversal, storms of similar intensity could become more frequent and their effects more severe. We're talking about potential widespread blackouts, damaged transformers that take months to replace, and infrastructure that might need complete redesign. Underground infrastructure faces risks too. Pipelines, railway signals, and telecommunications cables can all experience induced currents during geomagnetic disturbances, accelerating corrosion and causing equipment failures. But what about the effects on life itself? Will we be bombarded with lethal cosmic rays? The short answer is no. Earth has two protective shields, not one. Our atmosphere is equivalent to about 10 meters of water in terms of shielding power. Even if the magnetic field dropped to 10% of its current strength, the atmosphere would still block the vast majority of harmful radiation from reaching the surface. There would be some increase in radiation levels, particularly at high altitudes and near the poles. Airline crews and frequent flyers might receive higher doses. The ozone layer presents a more concerning issue. When high-energy particles from space penetrate deeper into the atmosphere during periods of weak magnetic field, They can trigger chemical reactions that destroy ozone molecules. Studies of past reversals show evidence of ozone depletion events. More UV radiation reaching the surface could increase rates of skin cancer and could affect plankton populations in the oceans, which form the base of the marine food chain. Then there's the question of animal navigation. Many species use Earth's magnetic field as a compass. Sea turtles navigate across entire ocean basins using it. Birds use it for migration. Some fish, whales, and dolphins rely on it for long-distance navigation. During a reversal, with multiple poles and a chaotic field, how would these animals cope? The fossil record provides some reassurance. Scientists have looked for evidence of mass extinctions coinciding with magnetic reversals and haven't found clear correlations. Life has survived hundreds of these events. This suggests that animals might switch to backup navigation systems using the sun, stars, landmarks, or smell. The transition happens slowly enough that many generations pass, allowing for adaptation. However, we can't be complacent. The species that exist today evolved in a world with a stable magnetic field for 780,000 years. Migratory species that travel long distances might face particular challenges. And in a world already stressed by climate change, habitat loss, and pollution, an additional stressor could have unforeseen consequences. There's another factor to consider: the potential loss of atmosphere. Mars lost most of its atmosphere billions of years ago, and scientists believe the loss of its magnetic field was a contributing factor. Could this happen to Earth? The good news is that Earth is much larger than Mars, with stronger gravity that helps hold onto our atmosphere. Even during a complete reversal lasting thousands of years, the amount of atmosphere lost would be negligible. What about climate effects? Some scientists have proposed that cosmic rays might influence cloud formation, potentially affecting temperature. However, this hypothesis remains controversial and unproven. Studies of past reversals don't show clear climate signals that coincide with magnetic changes. So, let's bring this all together. What will the upcoming magnetic flip actually do to Earth? The transition will likely take thousands of years. During this time, we'll experience a weakened and more complex magnetic field. Our technology will face the greatest challenges, requiring innovation and investment to maintain our satellite networks, power grids, and communication systems. Life on Earth will continue. The atmosphere will protect us from most radiation. The ozone layer might thin in some areas, requiring us to be more cautious about UV exposure. Some animal species might struggle with navigation, but adaptation will occur. There won't be catastrophic extinction events or loss of our atmosphere. What makes this upcoming reversal different from all previous ones is that humans will be here with our complex technological civilization. We've built a world that depends on precise navigation, reliable power, and constant communication. These systems will be tested in ways they've never been tested before. If you found this deep dive into Earth's magnetic future fascinating, make sure to subscribe to our channel. We're constantly exploring the science behind our changing planet. Hit that subscribe button and the notification bell so you don't miss our next video. Let me know in the comments what aspect of the magnetic reversal interests you most. Thanks for watching, and I'll see you in the next one.